How AI works. John McCarthy, the father of artificial intelligence, conceived the best model for computer artificial intelligence that could solve new problems, brand new problems that the AI was never coded to solve, would be to make a program design that simulated the human brain. And so, remarkable as it was, artificial intelligence was modeled after the human brain as far back as 1956, over 67 years ago. Of course, AI implementation, its engineering below the hood, has evolved a lot since 1956, 67 plus years ago. So we will focus more on the concepts and less on the hardware or software engineering and specific implementations. So we will focus on a broad understanding of artificial intelligence, of AI, and how it works. Let's look at how the human brain compares to the artificial intelligent AI brain. Let's talk about neurons, about human brains and how they use neurons to store information and associations and contexts and instructions. AI brains, like human brains, use coded computer neurons that emulate human neurons. They store information and associations and contexts and instructions, just like humans. AI brains receive information as data inputs into their neurons, just like human brains receive inputs from dendrites into their neurons. Neurons are the communication system throughout both the human and the artificial intelligent AI brain. Let's talk about the neuron nucleus of the human and the AI neuron. The nucleus is the data center and the brains of the neuron in human beings and in AI. Inside, at the core of a neuron, is what is called the nucleus. The nucleus is the container. That is to say, it is the center inside the neuron. The nucleus stores the neuron's contents and its instructions. The nucleus holds what the neuron knows, and the nucleus holds what the neuron is instructed to do. For humans, the nucleus contains DNA and more. For artificial intelligence, the nucleus contains its directives, its associated data, and its influence weights. So let's talk about dendrites as human inputs and AI inputs. Human brains, they use dendrites to receive information from other neurons and from the environment. AI brains use data inputs to receive information from other AI neurons or from other external data inputs, like written language, books, articles, like photographs, images, music, and so forth, or things like science and technology and that sort of thing. Well, let's talk about the axons and AI activation functions and their outputs. Human brains use axons to transmit what their neurons need to output. AI brains use what is called activation functions to decide what to do with its neuron contents. AI brains mirror human brains' axons by transmitting the results of their activation functions. AI brains transmit the resulting axon data through their neuron data outputs, just like human brains export their results through their axon terminal outputs. Let's talk about neural networks. The human brain uses a biological network of neurons called a neural network to manage neurons. AI uses the human brain's neural network design and function just the same. It is used as the AI's basis for its own internal artificial neural network, which again closely mimics and emulates the human brain's operation, function, and flow of data. Using neurons in an artificial neural network is key to human and AI intelligence. Therefore, artificial neural networks are comprised of, you guessed it, a lot of neurons. Before moving on, here's an interesting fact. Comparing the number of neurons in a human brain to an AI brain. The human brain has about 86 billion neurons. That's right, 86 billion neurons. Current AI brains have nearly 200 billion neurons. You got it, 200 billion. And they will only get bigger and more powerful by adding more hardware and storage. For the first time in history, artificial intelligence literally outcomputes any human. And again, AI will only grow in its prowess and its power, while humans remain fixed and constant in our memory and in our own processing limited power. Well, it's time to move on. Let's talk about AI, rewards, and motivation. Like the human brain, AI has a reward system to motivate it to do the right thing. It has its own high-tech dopamine reward system that mirrors the motivation reward system of the human brain. Remember, AI has formal directives and goals that it strives to achieve. And AI has a lot of data that represents both good and bad content and things, from which it wants to use only the good data and to avoid the bad data. And it seeks to complete and not violate its directives and goals. And the AI wants to avoid any action or any decision or any data that contravenes its directives or its goals. Just like people seek to do things that release dopamine so they feel good, so too does AI seek to score or earn the most dopamine, otherwise reward points as possible. It will do so always, relentlessly. Human brains function and think on many things at the same time. AI brains use concurrency to operate AI subsystems and processes simultaneously in parallel. They instantiate many tiny jobs that must be executed by what is known as a job manager. The job manager runs all jobs simultaneously, moving data to and from AI neurons for communication. The job manager coordinates and aids things like preloading predicted, anticipated, most probable, next needed, related, or associated information, instructions, or data from other neurons. The job manager coordinates with neurons for their instructions and data. You can see how artificial intelligence brains are very closely modeled after human brains and how they function. We will cover the parallels of the AI brain with the human brain as we proceed. For now, let's look at the parallels quickly together. The human brain and AI brain have similar world and data input and neuron communication systems that drive awareness and inter-system communication, that drive AI sentience. The human brain and AI brain have similar learning and choice analysis systems that drive learning and associations and pattern recognition and general insight. The human brain and the AI brain have similar reward systems that drive desired motivation and ultimate behavior. Both the human and the AI brain have billions of neurons coursing through their brains at the same time. It is no wonder that as hardware and storage caught up with the conceptual architecture behind AI, that the conceptual AI matching human brains became real, that artificial intelligence became real in our world.